All right, I need to erase to make room. Here we have an airplane flying completely horizontally, the perfect world in Mathland, at 1 mile. So here's my plane, and it's 1 mile above ground, and there's the plane moving that way. And this is ground. Okay, it flies over a tracking station on the ground. Okay, so here we go, tracking station. If the distance between the station and the plane, I even wrote it down here, so just so you're clear, that's this distance, right? If that distance is increasing at 400 miles an hour, so I'm just going to call it C. So dc over dt is 400, and it's getting bigger because the plane is moving away, right? And let's see, what else do they give us? When that distance is 10, so when c equal 10, so what are they asking me to find? What is the speed of the plane? How fast is the plane moving? Well, this is the path of the plane. So I'm going to label that P, and what they're asking me to find is dP over dt. All right, looking for an equation that has P and C and my fixed number of 1. Again, you see Pythagorean. C squared is P squared plus 1 squared, taking the derivative. Then I'm going to take and cancel the 2's. So let's see what I've got. I can plug in C equal 10. I can plug in 400, and I've got P times dP dt. That's what I'm trying to find. So now is the time I use my when information to find out what the P is equal to. So I'm just going to draw a different picture. So here I'm going to put C is equal to 10, and there's 1. So if I'm trying to find P, that's like saying the square root of 100 minus 1, right? So P is root 99. So that means I get 4,000 over root 99 is dP over dt. Right, so here we got 2 ships leaving from the same dock. So they're leaving from here. So ship A is sailing east. So I'm not going to label this ship as A. I'm going to label the length that this distance is growing. So I can say if that's the length of A, dA over dt is growing at 35 kilometers per hour. Then what else do I have? I've got ship B sailing north. So here's B. I'll call it the length here B, not the ship. And so then dB over dt is 25. Okay, so what are they asking me to find? How fast is the distance between them changing? I'm going to be super creative. C. So find dC over dt. And what is the when information? Oh, they say 4 p.m. Oh, and it started at noon. I'm just going to put when t equal 4, and I'll figure out what that means later. Okay, let's dig in. So I get c squared is a squared plus b squared. Now I'm going to take the derivative. So 2c dc dt equals 2a dA dt plus 2b dB dt. Oh, look at all those things. Cancel the 2's as we can. And let's go slow and plug some things in. So what do I know? I don't know here, so I'm just going to carry this along. And I'm going to say A. Don't know that yet, but dA over dt is 35. B, don't know that yet. And dB over dt is 25. So let's think about it. So if I've been traveling for 4 hours, let's think about A here. So 35 kilometers per hour. And if I multiply that times 4, that gives me the amount of kilometers. So 35 times, whoops, 35 times 4 is 35, 140. 140. So that's the A. So I get to plug that in. And there's times 35 plus. And I can multiply 25 times 4 to find the B. Much easier, 100. And then how do I find the C? Well, I'm just going to take liberties here because you know C is going to be the square root of A squared, 140 squared, plus B squared, 100 squared. And that's a fine answer for me.